Hello everybody and welcome to the chapter of human resource. In this video we will be talking about some of the typical problems that you may come across, when I say problems, like end of the textbook problems. um, First one is how to calculate the various times, like average observed time, standard time, and normal time. In the order of average observed time, normal time, and standard time. Okay, so in the first question, in this case we are given um, the average observed time of 12 seconds and rating as 100% that I wrote as 1 in the cell so that I can use it in my calculations. And then the firm has a potential fatigue and delayed allowance of 15%. So when I say 15%, that means 0.15 as something that we can use. So when we calculate as normal time, before we get to the standard time, I need the formula for normal time. Okay, so there we have it. So normal time is defined as, let me get this out of the way for now. So normal time, come on, okay. Now normal time is defined as average times multiplied by the performance rating, which is 1, so it doesn't change much. And then I'm going to make sure that it's highlighted as calculation. Now the standard time now is, so let's bring this somewhere closer. Let's say here. Standard time is now defined as normal time, so equals to normal time divided by 1 minus, in parentheses, 0.15. I'm going to close it as such. So the standard time for this process is about 14 seconds. Yeah. Now let's look at this way. For the person who was observed, had an average of about 12 seconds time, but the standard time that should be allowed for that activity is about 14%, given the fact that we are allowing 15% of fatigue delay. Okay, so now let's look at another example. So Charlene Brewster has a time of, these are the observed times for her, and then performance rating is about 110%. So she is 10% more than the average person. And so first thing is to calculate average observed time. So I calculate average observed time comes out to be 8.5. Now the normal time therefore will be 8.5 seconds times 1.1. This is how much a normal person with only 100% performance rating will take. So that the normal person will take longer. Now the question is she faster than normal? Of course she's faster than normal. First of all, because she takes less time than the normal time. That's one hint. The second one is that her performance rating itself is about 10% more. So Charlene is faster than normal. Okay. Now, in the next set of questions, we are given the allowance factor as 15%. This is in continuation to the previous question. So we've been told the allowance factor is this. Then what's the standard time? Well, the standard time is given to us as, you remember, normal time divided by 1 minus allowance factor over here on the right side. Yeah, so normal time divided by 1 minus allowance factor. So we will do the same thing here, equals to the normal time that we just calculated, normal time divided by, in parentheses, 1 minus the allowance factor. Cool. Now in the next one, we've been given two different new numbers. If the allowance factor was 18% instead of 15%, and the performance rating is now 90%. So instead of somebody like Charlene, who was 10% faster than the normal person, this time the performance rating is only 90%. So we need to calculate the new normal time. Instead of 9.35, the new normal time is going to be the performance rating times the average time. So if somebody with only 90% performance rating can get stuff done in 8.5 seconds, the normal person should be able to do it a lot sooner, whose performance rating would be 100% instead of 90%, which is if somebody who has only 90% of the capability for of a normal person can get some stuff done in 8.5 seconds on an average, the normal person should be able to do it a lot sooner because they'll have 10% more capability than that the person in question. Therefore, now the standard time is going to be normal time divided by 1 minus the allowance factor, which is 18% this time. So we are allowing for a lot more relaxed policy-wise. So we are talking about 9.3 seconds and so on. Okay, so let's look at this. We've been given this set of information. So first thing is, let's calculate the average time. So instead of going to the right of it, to help with the recording of the screen, I'm going to write it over here, average time, and let's say normal time and standard time. Okay, so first thing I'm going to take the average of the given observations. So I'm going to go from the grasping the bag. Well, I think I can fit these three in there, otherwise I'll end up typing the tasks as well. So average, come on, average of these 5 numbers. Gonna color this slightly, and then for all these numbers that are given to me, then for this one equals to average of 3641, and that's where I'll stop because 112 looks like an outlier. So this, and then equals to average of all of these numbers, okay, and then equals to average of, let's say, these 3 numbers. Okay, now these are outlier situations. I mean, this is a textbook question, so we are only trying to I'm only trying to demonstrate the concept that the textbook chapters are trying to highlight, that when you're taking these observations, need not be taken away by these outlier observations. Now normal time would then be average times multiplied by the individual performance ratings. So that gives us our normal times, Control Shift 1, then calculate normal times, and now the standard times are going to be, do we have the allowance factor? Yes, we do. So we know the allowance factor is given to us as 0.23. So therefore, standard time is going to be normal time divided by 1 minus 0.23, and I'm going to freeze it so that I can copy it down. Control Shift 1, Control C, Control V, Control S, and then let's say choose a different color. Okay, so I have average, normal, and standard times. Now let's go ahead and start calculating the sample things. Okay, now for the samples, we know required sample size is given by n equals to z s by h x bar, everything together squared, wherein h is the accuracy level, z is the number of standard deviations required, the desired level of confidence, and x bar is the mean of the initial sample, and n would be the required sample size. Okay, so let's start calculating these one thing at a time. Okay, so first thing I'm going to do is calculate the z. Okay, now sorry, small z, and then I'm going to calculate s, I'm going to calculate h, I'm going to calculate X bar. Okay, now we know that they want us all of these things to be calculated for certain given parameters. We want to find out the z-score for 99% confidence level, so about 0.99. So I'm going to calculate this as equals to norm SINV for 99%. So either you can type it down, but I'm going to refer to this and freeze it. 1, 2, 3, 4. Okay, 1 for each of these. Okay, so excuse me, and then S is for the standard deviation. Now again, when we calculate the standard deviation, you need to calculate this for the same number of variables that we calculated the average for. Okay, so when I do standard deviation, I'm going to do it for the same. That was the reason why I colored this out, so then I don't make the mistake. So the first one is like this, and then equals to STDEV, standard deviation of these 4 numbers. And then the third one, so let me check average time, so it's for all of these. Okay, so I'm gonna color these so then I don't make a mistake here. So equals to STDEV for all of these numbers, and then for the first 3 numbers only. Now H is given to us as 5% accuracy, so 0.05, 0.05, 0.05, 0.05, so that's given. So I'm going to color them accordingly. These numbers are all calculated, so I'm going to color them differently. And then X bar, we already have it calculated. This would be our X bar. Okay, so let me bring these numbers here. Control Shift 1, so then the formatting does not make us take us for a ride. What is the same color? Okay, almost there. Okay, now I'm going to calculate the numerator versus denominator for this part. So first thing I'm going to calculate is the numerator part. So first I want to calculate this part only. Okay, so in order to do that, I'm going to calculate z times s. Okay, so let's look at this. Equals to z times s. So that's this. Control Shift 1, Control C, copy it all the way. Then I'm going to calculate h times x bar. H times x bar is h times x bar. Now you can do this all in single cell, but I'm just showing it for the purpose of demonstration here to make things simple, so then if you make a mistake you can narrow it down. So this is the numerator part. This is the denominator. So then I'm going to do numerator divided by denominator, and then raise to the power square. Raise to the power square. So also this would be my final number that I'm trying to calculate. So within parentheses, this divided by this, shift 6 raised to the power 2. So these are the sample sizes that we need as the final answer for each of them. Okay, so the number of minimum samples we should take for each of these activities instead of the 5 that are given to us is about 68 observations that we should be taking for grasping and placing the bag. We should take about 12 observations as a sample size, acceptable sample size, instead of the 4 observations that are given to us and we should have 58 observations for the 5 observations that are given for sealing the bag, and we should have about 86 observations for placing the bag on the conveyor belt instead of the only 3 given to us, or 3 acceptable out of the 5 readings that were taken. Okay. Now, one thing I would like to point out is I wanted to keep things simple so far. So far, we've been told, I have used, let's say, draw, that we are looking for 99% confidence interval. So let's look at this one. If we have a graph, my bad. Let's say if we have a graph that looks something like this. Let me try another shot. A graph that looks like this. We are looking at 99%. Okay, so if we look at total of 99%, we have about 0.5% on this side and 0.5% on this side. So when we are looking at the z-table from left to right, we are looking at theoretically 99.5%. Okay, so essentially when we are looking at this value is for 99%, when we are calculating the z-score, we should be calculating it for 99 plus 0.5 of this area. Okay, because when you look at from the leftmost origin to where the 99% actually happens, you have about half of that 1% to be added on the left tail. Okay, so when you will actually calculate this, I want to make this as a correction that the reason I'm showing this at the end is because I didn't want to calculate the whole the problem, but this would be 0.99 plus 1 minus 0.99 and this whole thing by 2. Okay, so this is what gets added for from the left tail to the original 99% area under the graph. Okay, so when we look at this norm SINV, this needs to be 0.995. So it'll make a slight change, but everything else stays exactly the same. So your final answer should be interpreted based on these 4 numbers. Okay. This is a conceptual part. I mean, if for the normal standard distribution, but this should not complicate or influence all of the rest of the calculation, which is based on this formula. Okay, so let's say if we were to figure out somehow how to calculate the z value for a corresponding 99% confidence, this is exactly what you'll find on the on anywhere on the tables. Okay, so that's not pretty difficult to find. Okay, and that's all there is to the variety of problems for this chapter. Thanks. If you have any questions, feel free to email me. Have a nice day. Bye bye.